BDD stands for Behaviour Driven Development. But what does that mean? What does it mean to do BDD? Well, BDD is a way for software teams to work that closes the gap between business people and technical people by encouraging collaboration across roles to build shared understanding of the desired behaviour of the system, producing system documentation that guides development and is automatically checked against the system's behaviour, working in rapid small iterations to increase feedback and the flow of value. Doing BDD involves doing three things over and over again. First, you take a small upcoming change to the system, like a user story, and have a conversation to explore, discover and agree on the details of how we want the system to behave, using concrete examples. Next, you document those examples in a way that could be automated, and check for agreement. Finally, you actually get coding and implement the behaviour described by each documented example, starting with an automated test to guide the development of the code. We call these three practices discovery, formulation, and automation. The idea is to make each change small and iterate rapidly, moving back up a level each time you need more information. Every time you automate and implement a new example, you've added something valuable to your system, and you're ready to respond to feedback. Over time, the documented examples become an asset that enables your team to continue confidently and rapidly making changes to the system. We call this living documentation because the code reflects the documentation and the documentation reflects the team's shared understanding of what the code does. This shared understanding and the living documentation is constantly evolving. Cucumber is a tool that facilitates BDD. We can't teach you about Cucumber without teaching you about BDD too, so that's where we're going to start. A prerequisite for doing BDD is to have an agile process in place. BDD needs to be done just in time at the last responsible moment, because we place a lot of emphasis on conversations rather than trying to write everything down. If you try to have those conversations too far ahead of doing the work, you'll have forgotten most of what you talked about. So you need to have your work already broken down into user stories. Ideally, you'll have also started to define acceptance criteria or business rules for those stories. But they don't need to be exhaustive yet. We'll flesh them out during the BDD process. Let's imagine we're building a point of sale system for an electronics retailer, Dixie's. Here's our next user story: process refunds. In order to satisfy customers' statutory rights, as a sales assistant, I need to be able to process refunds. In order to prepare this story for development, we have what we call a Three Amigos meeting. We call it the Three Amigos because it involves three different disciplines from the team: test, development, and product. Let's watch one in action.
The business rules for this story are really simple. Any item can be returned within 14 days as long as the customer has a receipt.
Can you give me an example?
Okay. Colin, the customer, bought a kettle last week from us. When he got home, he realised the colour didn't match his kitchen cabinets and he really didn't like it. He's brought it back to the store for a refund. He walks up to Sally, a junior sales assistant, and he asks her to process the refund.
What's the outcome here? What are we supposed to test?
Well, we need to increment the stock quantity for that item so we know it's back in our inventory.
Right, anything else?
No, I think that's all.
What if Colin doesn't have his receipt? Does Sally have to send him home?
Well, a manager can process a refund with any proof of purchase. Colin could use a bank statement, for example, but Sally can't do that, so she would have to ask her boss.
Right, so there are two rules here. The customer must have proof of purchase, not just the receipt. And if they don't have their receipt, then it must be authorised by a manager, right?
Oh, right, exactly.
Aren't we forgetting something here? Isn't Colin supposed to get his money back?
Oh, yes, of course.
And does the system need to notify anyone in the warehouse to come and pick up the kettle?
Good idea, Tommy. Yes. I think that's out of our scope for this version of the story, but I'll put it on the backlog for future iteration.
As you can see, the Three Amigos meeting raises lots of questions. It's a really useful way to discover assumptions and potential misunderstandings. It is also a great way to communicate requirements that somebody might have thought about, but never explained clearly to other people on the team. Sometimes the Three Amigos will hit a question that nobody in the room knows the answer to. These are also a valuable output from the meeting. Now you have a clear picture of what you know and what you need to find out. Talking through examples is a great way to get everyone on the same page about what needs to be built. Once all Three Amigos are happy that they understand the story, then you can start translating your examples into something that Cucumber can understand. Here's one of our examples written out in Gherkin, the specification language for Cucumber. As you can see, Gherkin's almost like plain English. We have to use a few special keywords so that Cucumber can understand it too. Words like feature, scenario, given, when, and then. You'll learn all about these soon. We can refine as many examples as we need into this form to create an executable specification for our software. Shouty is a social network that allows people who are physically close to communicate, just like people have always communicated with their voices. In the real world, you can talk to someone in the same room or across the street, or even 100 meters away from you in a park, if you shout. That's Shouty. What you say on this social network can only be heard by people who are nearby. Let's start with a very basic example of Shouty's behaviour. Something we might have discussed in a Three Amigos meeting. Sean the shouter shouts, "Free bagels at Sean's!" And Lucy the listener, who happens to be stood across the street from his store, 15 metres away, hears him. She walks into Sean's coffee and takes advantage of the offer. We can translate this into a Gherkin scenario so that Cucumber can run it. Here's how that would look. You can see there are 4 special keywords being used here. Scenario just tells Cucumber we're about to describe an example that it can execute. Then you see the lines beginning with given, when, and then. Given is the context for the scenario. We're putting the system into a specific state ready for the scenario to unfold. When is an action, something that happens to the system that will cause something else to happen, an outcome. Then is the outcome. It's the behaviour we expect from the system when this action happens in this context. You'll notice we've omitted from our outcome anything about Lucy walking into Sean's store and making a purchase. Remember, Gherkin is supposed to describe the behaviour of the system, so it would be distracting to have it in our scenario. Each scenario has these 3 ingredients: a context, an action, and 1 or more outcomes. Together, they describe one single aspect of the behaviour of the system: an example. Now that we've translated our example into Gherkin, we can automate it. The easiest way to get started with Cucumber for Java is to use a template project with a build script that sets everything up correctly. You can download this template project from GitHub. Open your web browser and go to the Cucumber Java Skeleton project on GitHub. If you're comfortable with Git, you can just clone the project. If you're new to Git, don't worry. We'll download a zip file instead. Click Releases, then download the most recent zip file that starts with a V. On Windows, extract the zip file by double-clicking on it. Or if you're on OS X or Linux, extract it with the unzip command. After extracting the zip file, we'll rename the directory to Shouty. In your shell, cd into the Shouty directory. The template project contains Maven and Ant build scripts that makes it easier to get started with Cucumber for Java. We'll be using Maven, so if you haven't already installed that, now's a good time to do it. Let's take a look at what else is in this project. There is a main directory for our application code under source, and a test directory for our test code. Let's remove some of the files that come with the project that we don't need. Remove belly.java, stepdefinitions.java, and belly.feature. Now we have a bare bones project. We'll be building it from the ground up so you can see what is going on. Before we open the project in our IDE, we're going to modify the name of the application. Open pom.xml and change the group ID, artifact ID, and name. We are ready to start coding. We're going to use IntelliJ IDEA Community Edition because it has really nice Cucumber integration built in. If you prefer to use a different IDE such as Eclipse, that's fine too. To open the project in IntelliJ, just open the pom.xml file. Before we create any files, let's rename the package from skeleton to shouty. In IntelliJ, you can rename it via the refactor menu. Now we're ready to create our first feature file. Let's create our first feature file. Call the file here_shout.feature. All feature files start with the keyword feature, followed by a name. It's a good convention to give it a name that matches the file name. Now let's write out our first scenario. Listener is within range. Given Lucy is located 15 meters from Sean. When Sean shouts, "Free bagels at Sean's," then Lucy hears Sean's message. Now we have a scenario. It's time to run it. Switch back to the command prompt and run maven clean test. Maven will now download Cucumber, compile your code, and tell Cucumber to run your feature file. You'll see that Cucumber has found our feature file and read it back to us. We can see a summary of the results at the bottom. 3 steps, 1 scenario, all undefined. Let's run the scenario again from inside IntelliJ. Select the feature file and choose Run from the context menu. This will give you similar output. Undefined means Cucumber doesn't know what to do for any of the 3 steps we wrote in our Gherkin scenario. It needs us to provide some step definitions. Step definitions translate from the plain language you use in Gherkin into Java code. We write a Java method, then annotate it with a pattern. When Cucumber runs a step, it looks for a step definition with a matching pattern. If it finds one, then it executes the method. If it doesn't find one, well, you've just seen what happens. Cucumber helpfully prints out some code snippets that we can use as a basis for new step definitions. Let's copy those. We'll create a new class in the shouty package where we'll paste those snippets. Make sure you create it under test and not main. Now IntelliJ is complaining that there are some unknown symbols. We need to add some import statements. Pressing Alt-Enter will do that for us. Let's return to the scenario and run it again. There is a small bug in IntelliJ's Cucumber integration. Sometimes it doesn't tell Cucumber where to find step definitions. This is easy to work around. Just edit the run configuration and make sure the glue field contains the value of your package. Now we can run it again. This time the output is a little different. We now have a pending step and 2 skipped ones. This means Cucumber found all our step definitions, hooray, and executed the first one. But the first step definition throws a pending exception which causes Cucumber to stop, skip the rest of the steps, and mark the scenario as pending. Now that we've wired up our step definitions to Gherkin steps, it's almost time to start working on our solution. First though, let's tidy up the generated code. We'll rename the int parameter something that better reflects its meaning. We'll call it distance. We can print it to the terminal to see what's happening. If we run it again, we can see the number 15 pops up in the output. Notice that the number 15 does not appear anywhere in our code. The value is automatically passed from the Gherkin step to the step definition. If you're curious, that's the int in the step definition pattern or Cucumber expression. We'll explain these patterns in detail in a future lesson. Now that we have our step definitions matching, we can start working on our solution. We like to use our scenarios to guide our development, so we'll start designing the objects we need by sketching out some code in our step definitions. The scenario will be failing while we do this, but we should see the error messages gradually progressing as we drive out the interface to our object model. Our next goal is for the scenario to fail because we need to implement the actual business logic. Then we can work on changing the business logic inside our objects to make it pass. To implement the first step, we need to create a couple of person objects, one for Lucy and one for Sean. Then we create the person class to remove the errors and specify the distance between them. We can remove the pending status now in this print statement and write the implementation for the first step like this, and create the moveTo method in the person class. We have two instances of person, one representing Lucy and one representing Sean. Then we call a method to move Lucy to the position specified in the scenario. To keep things simple, we're going to assume all people are situated on a line, a one-dimensional coordinate system. We can always introduce proper geolocations later. We'll place Sean in the centre and Lucy 15 metres away from Sean. When we run the scenario, the first step is green. We're making progress. We'll keep working like this until we see the scenario failing for the right reasons. In the second step definition, we want to tell Sean to shout something. In order to send instructions to Sean from the second step, we need to store him in an instance variable so that he'll be accessible from all our step definitions. In IntelliJ, we can do this by using the introduce field refactoring. In the when step, we're capturing Sean's message inside the string pattern, so let's give that argument a more meaningful name. Now we can tell him to shout the message. And we eliminate the compilation error by implementing the shout message in the person class. When we run the scenario again, now the second step is green. The last step definition is where we implement a check or assertion. We'll verify that what Lucy has heard is the same as what Sean shouted. Once again, we're going to write the code we wish we had. In order for this to be able to compile, we need to import the assert equals static method from JUnit and the array as list method. So we need a way to ask Lucy what messages she's heard, and we also need to know what it was that Sean shouted. We can record what Sean shouts by storing it in an instance variable in the when step. This is a common pattern to use in Cucumber step definitions when you don't want to repeat the same test data in different parts of a scenario. Now we can use that in the assertion check. We also need to add a messages heard method to our person class. Let's do that now. Just return null for now. And watch Cucumber run the tests again. This is great! Whenever we do BDD, getting our first failing test is a milestone. Seeing the test fail proves that it is capable of detecting errors in our code. Never trust an automated test that you haven't seen fail. All we have to do is write the code to make it do what it's supposed to do. So we have our failing scenario. Lucy is expected to hear Sean's message, but she hasn't heard anything. We got an empty array back from the messages heard method. In this case, we're going to cheat. We have a one-line fix that will make this scenario pass, but it's not a particularly future-proof implementation. Can you guess what it is? I told you it wasn't very future-proof. Great! Our scenario is passing for the first time. As long as this is the only message anyone ever shouts, we're good to ship this thing. Now, the fact that such a poor implementation can pass our tests shows us that we need to work on our tests. A more comprehensive set of scenarios might have guided us towards a better implementation. It's also a good habit to look for the most simple solution. We can trust that, as our scenarios evolve, so will our solution. This is the essence of behaviour-driven development. Examples of behaviour drive the development. We do just enough to make the next scenario pass, and no more. Instead of writing a note on our to-do list, let's write another scenario that shouts a different message. It will fail, reminding us that we need to find a solution that doesn't rely on a hard-coded message. Now, when we come back to this code, we can just run the tests, and Cucumber will remind us what we need to do next. We're done for today. Of course, if you're in the mood, you can always try to implement a solution yourself that makes both scenarios pass. Have fun! In the previous chapter, we explored the fundamental components of a Cucumber test suite and how we use Cucumber to drive out a solution, test first. First, we specified the behavior we wanted using a Gherkin scenario in a feature file. Then, we wrote step definitions to translate the plain English from our scenario into concrete actions in code. Finally, we used the step definitions to guide us in building out our very basic domain model for the Shouty application. We tend to think of the code that actually pokes around with the system as distinct from the step definitions, so we've drawn an extra box labelled automation code for this. Automation code can do almost anything to your application. It can drive a web browser around your site, make a HTTP request to a REST API, or, as you've already seen, drive a domain model directly. Automation code is a big topic that we'll come back to. First, we want to concentrate on step definitions. Good step definitions are important because they enable the readability of your scenarios. The better you are at matching plain language phrases from Gherkin, the more expressive you can be when writing scenarios. Teams who do this well refer to their features as living documentation, a specification document that never goes out of date. When Cucumber first started, we used to use regular expressions to match plain language phrases from Gherkin steps. Regular expressions have quite an intimidating reputation. So we replaced them with something simpler, something we call Cucumber expressions. Cucumber is backward compatible, so you could still use the power of regular expressions if that's your thing. This chapter is all about Cucumber expressions. Let's look at the Shouty scenario from the last chapter. As Cucumber starts to execute this feature, it will come to the first step of the scenario, given Lucy is located 15 meters from Sean, and say to itself, now, do I have any step definitions that match the phrase, Lucy is located 15 meters from Sean? The most simple Cucumber expression that would match this step is this one. That's pretty simple, isn't it? Cucumber expressions are just string patterns, and the most simple pattern you can use is a perfect match. In Java, we can use this pattern to make a step definition like this. We use a normal Java string to pass the Cucumber expression to Cucumber. Sometimes we want to write step definitions that allow us to use different values in our Gherkin scenarios. For example, we might want to have other scenarios that place Lucy a different distance away from Sean. To capture interesting values from our step definitions, we can use a feature of Cucumber expressions called parameters. For example, to capture the number of meters, we can use the int parameter, which is passed as an argument to our step definition. Now we're capturing that value as an argument. The value 100 will be passed to our code automatically by Cucumber. Because we've used Cucumber expressions built-in int parameter type, the value has been cast to an integer data type for us automatically, so we can do maths with it if we want. Cucumber has a bunch of built-in parameter types: int, float, word, and string. You can also define your own, as we'll see later. Although it's important to try to use consistent terminology in our Gherkin scenarios to help develop the ubiquitous language of your domain, we also want scenarios to read naturally, which sometimes means allowing a bit of flexibility. Ideally, the language used in the scenarios should never be constrained by your step definitions. Otherwise, they'll end up sounding like they were written by robots. Or worse, they read like code. One common example is the problem of plurals. Suppose we want to place Lucy and Sean just 1 meter apart. Because we've used the singular meter instead of the plural meters, we don't get a match. What a pain! Fear not. We can just surround the S in parentheses to make it optional, like this. Now our step matches. This is one way to smooth off some of the rough edges in your Cucumber expressions and allow your scenarios to be as expressive as possible. Another way is to allow alternates. different ways of saying the same thing. For example, to accept this step, we can use this cucumber expression. Now we can use either the word standing or located in our scenarios, and both will match just fine. Although you can get a long way with cucumber expressions built-in parameter types, you get real power when you define your own custom parameter types. This allows you to transform the text captured from the gherkin into any object you like before it's passed into your step definition. For example, let's define our own person custom parameter type that will convert the string Lucy into an instance of person automatically. We can start with a step definition, which would look like something like this. If we run Cucumber at this point, we'll see an error because we haven't defined the person parameter type yet. Here's how we define one. Let's create a new Java class called parameter types in the shouty.support package. We're going to create a person method which takes the name of a person as a string and returns an instance of our person class with that name. Cucumber will use the method name person as the parameter name we use inside the curly brackets in our step definition expressions as soon as we've wired it up. To do that, we add the parameter type annotation, import it, and pass it a regular expression. This is necessary to tell Cucumber expressions what text to match when searching for this parameter in a gherkin step. We won't go into the details of regular expressions in this video, but in this case, we're just matching on either of the names of the people we're using in our scenario. All of this means that when we run our step, we'll be passed an instance of person into our step definition automatically. Custom parameters allow you to bring your domain model, the names of the classes and objects in your solution, and your domain language, the words you use in your scenarios and step definitions, closer together.
In the previous chapter, we talked about the importance of having readable scenarios, and you learned some new skills with Cucumber expressions to help you achieve that goal. Those skills will give you the confidence to write scenarios exactly the way you want, knowing you'll be able to match the gherkin steps easily from your step definition code. We emphasize readability because from our experience, writing gherkin scenarios is a software design activity. Cucumber was created to bridge the communication gap between business domain experts and development teams. When you collaborate with domain experts to describe behavior in Gherkin, you're expressing the group's shared understanding of the problem you need to solve. The words you use in your scenarios can have a deep impact on the way the software is designed, as we'll see in later chapters. The more fluent you become in writing Gherkin, the more useful a tool it becomes to help you facilitate this communication. Keeping your scenarios readable means you can get feedback at any time about whether you're building the right thing. Over time, your features become living documentation about your system. We can't emphasize enough how important it is to see your scenarios as more than just tests. Maintaining a living document works both ways. The scenarios will guide your solution design, but you may also have to update your Gherkin to reflect the things you learn as you build the solution. This dance back and forth between features and solution code is an important part of BDD. In this chapter, we'll learn about feature descriptions, the background keyword, and about keeping scenarios and code up to date with your current understanding of the project. First, let's catch up with what's been happening on the Shouty project. While we were away, the developers of Shouty have been busy working on the code. Let's have a look at what they've been up to. We'll start by running Cucumber. Great! It looks like both these scenarios are working now. Both the different messages that Sean shouts are being heard by Lucy. Let's dig into the code and see how these steps have been automated. In the step definition layer, we can see that a new class has been defined, the network. We're creating an instance of the network here. Then we pass that network instance to each of the person instances we create here. So both instances of person depend on the same instance of network. The network is what allows people to send messages to one another. There are also a couple of new unit test classes in the Shouty package. One for the network class and another one for the person class. Unit tests are fine-grained tests that define the precise behavior of each of those classes. We'll talk more about this in a future lesson, but feel free to have a poke around in there in the meantime. The familiar mvn test command will run those unit tests as well as Cucumber. The first thing I notice coming back to the code is that the feature file is still talking about the distance between Lucy and Sean, but we haven't actually implemented any behavior around that yet. This happens to us all the time. We have an idea for a new feature, but then we find the problem is too complex to solve all at once, so we break it down into simpler steps. If we're not careful, little bits of the original idea can be left around like clutter in the scenarios and in the code. That clutter can get in the way, especially if plans change. We're definitely going to develop this behavior, but we've decided to defer it to our next iteration. Our current solution is just focused on broadcasting messages between the people on the network. In the next lesson, we'll clean up the feature to reflect that current understanding. After the feature keyword, we have a space in a Gherkin document to write any arbitrary text that we like. We call this the feature's description. This is a great place to write up any notes or other details that can't easily be expressed in examples. You might have links to wiki pages or issue trackers, or to wireframes. You can put anything you like in here, as long as you don't start a line with a Gherkin keyword like rule or scenario. In this case, we can add a high-level description of the Shouty application. Because Shouty doesn't yet filter by proximity, we can also write a to-do list here, so it's clear that we do intend to get to that soon. Changing the description doesn't change anything about how Cucumber will run this feature. It just helps the human beings reading this document to understand more about the system you're building. Our two scenarios are examples of how Shouty can broadcast a shout to other users. This is one of the main business rules, which we can document using the rules keyword. We'll learn more about this in a later chapter. The step, given Lucy is 15 meters from Sean, is misleading, since the distance between the two people is not yet relevant in our current model. The step definition calls the moveTo method on person, but the moveTo method doesn't actually do anything. Let's simplify this code to do just what it needs to do right now and no more. We can start from the scenario by changing this single step to express what's actually going on. We'll work on one scenario at a time and update the other one once we're happy with this one. Now the scenario names make sense, and we have two steps, each creating a person. Notice we're starting to reveal some more of our domain language here. We've introduced the words person and name. Person is already part of our domain language, so it's nice to have that revealed in the language of the scenario. Name may well become an attribute of our person soon, so it's also useful to have that surfaced so we can get feedback about it from the team. One thing we've lost by doing this is the idea that eventually the two people will need to be close to each other for the message to be transmitted. We definitely wouldn't remove detail like that unilaterally without discussing it with the other people who were involved in writing and reviewing this scenario. In this case, as well as adding it to the to-do list above, we've decided to document the range rule and write a couple of new empty scenarios to remind us to implement that behavior later. Let's press on. We can run Cucumber to generate new step definition snippets for the new steps and paste them into our steps file. In the next lesson, we'll look at a couple of ways that we can implement these new step definitions. We now have two step definitions to implement, and that presents us with a bit of a problem. We need the same instance of network available in both. We could just assume that the Lucy step will always run first and create it there, but that seems fragile. If someone wrote a new scenario that didn't create people in the right order, they'd end up with no network instance and weird bugs. We want our steps to be as independent as possible, so they can be easily composed into new scenarios. There are a couple of different ways to create this network instance in Java. The most straightforward is to create a network field and initialize it in the declaration of the step definitions class. Every time Cucumber runs a scenario, it creates a new instance of this class, so we'll get a fresh instance of the network for each scenario. As an alternative that can be useful if you have more complex setup to do, you can use a hook. We need an instance of network in every scenario, so we can declare a before hook that creates one before each scenario starts, like this. Now we can use that network instance as we create Lucy and Sean in these two new steps. It should be working again now. Let's run Cucumber to check. Good. Let's do the same with the other scenario. Now we can remove this old step definition. We know we'll need something like this in the future when we implement the proximity rule, but we don't want to second guess what that code will look like, so let's clean it out for now. Now we have one last bit of dead code left, the moveTo method on person. Let's clean that up too. Okay, so we've cleaned things up a bit to bring the scenarios, the code, and our current understanding of the problem all into sync. What's nice to see is how well those new steps that create Lucy and Sean match the code inside the step definition. When step definitions have to make a big leap to translate between our plain language description of the domain in the Gherkin scenario and the code, that's usually a sign that something is wrong. We like to see step definitions that are only 1 or 2 lines long, because that usually indicates our scenarios are doing a good job of reflecting the domain model in the code, and vice versa. One problem that we still have with these scenarios is that we're very fixed to only being able to use these 2 characters, Lucy and Sean. If we want to introduce anyone else into the scenario, we're going to be creating quite a lot of duplicate code. In fact, the 2 steps for creating Lucy and Sean are almost identical, apart from those instance variables. On a real project, we wouldn't bother about such a tiny amount of duplication at this early stage, but this isn't a real project. Let's play around with the skills we learned in the last chapter to make a single step definition that can create Lucy or Sean. The first problem we'll need to tackle is these hard-coded instance variable names. We can use a map to store all the people involved in the scenario. Let's try replacing Lucy first. We'll start by creating a new hash map in the before hook, like this. Now we can store Lucy in a key in that hash map. We'll use her name as the key, hard-coding it for now. Finally, where we check Lucy's messages heard, here in the assertion, we need to fetch her out of the hash map. With that little refactoring done, we can now try and make this first step generic for any name. Using your newfound Cucumber expression skills from the last chapter, you'll know that if we replace the word Lucy here with a word expression, we'll have the name passed into our step definition as an argument here. Now we can use that as the key in the hash map. If we try and run Cucumber now, we get an error about an ambiguous match. Our generic step definition is now matching the step, a person named Sean, but so is the original one. In bigger projects, this can be a real issue, so this warning is important. Let's remove the old step definition and fetch Sean from the hash map here, where he shouts his message. Great, we're green again. Let's switch back to the feature to show you one more technique for improving the readability of your scenarios. When we have common context steps, the givens, in all the scenarios in our feature, it can sometimes be useful to get those out of the way. We can literally move them into the background using a background keyword like this. As far as Cucumber is concerned, these scenarios haven't changed. It will still create both Lucy and Sean as the first things it does when running each of these scenarios. But from a readability point of view, we can now see more clearly what's important and interesting about these two scenarios. In this case, the message being shouted. Notice, we just went straight into when steps in our scenarios. That's absolutely fine. We still have a context for the scenario, but we've chosen to push it off into the background. Again, it's debatable whether we'd bother to use a background to do this on a real project, but this at least illustrates the technique. We rarely use backgrounds in our projects because although they can improve readability by removing the duplication of repeated contexts, they also harm readability by requiring people to read the background in conjunction with each scenario. To maintain trust in the BDD process, it's important to keep your features fresh. Even when you drive the development from BDD scenarios, you'll still learn lessons from the implementation that might need to be fed back into your Gherkin documentation. In this case, we discovered that we could find a smaller slice of this story and defer the business rule about proximity until our next iteration. Splitting stories like this is a powerful agile technique and one that BDD can help you master. Now we have a clean codebase and suite of scenarios that reflects the current state of the system's development. We're ready to start the next iteration. Welcome back to Cucumber School. Last time, we worked on cleaning up the shouty features to keep them in sync with the current status of the project. We stripped the scenarios back to only specify the behavior of passing messages between people. We made it clear that the proximity rule had not yet been implemented. You'll already remember from the Cucumber Expressions chapter how important it is to be expressive in your scenarios and keep them readable. In this chapter, we're going to learn some new tricks with Gherkin that will give you even more flexibility about how you write scenarios. Once again, the shouty developers have been hard at work implementing the proximity rule. Let's have a look at how they got on. Right, so those two scenarios we just left as placeholders, the one where the listener is within range and the one where the listener is out of range, they're both passing. Fantastic! If we look at our step definitions, we can see how they have been implemented. Let's review the changes to the feature file in more detail. We now have 4 scenarios, our original 2 from the last time we looked at the code, and the 2 placeholders we wrote as reminders. We used the second scenario, listener hears a different message, to triangulate and force us to replace the hard-coded message output with a proper implementation. Now we have a domain model that uses a variable for the message. There's an insignificant chance of this behavior regressing, so we can safely remove the second scenario. Keeping excess scenarios is wasteful. They clutter up your feature files, distracting your readers. When you run your features as tests, excess scenarios make them take longer to run than necessary. The one where a listener hears a message is a perfectly good way of checking that the message has been sent correctly. The first scenario has changed since we last looked at it. It now specifies the range of a shout and the location of Sean and Lucy. This scenario exists to illustrate that a listener hears the message exactly as the shouter shouted it. All the additional details are incidental and make the scenario harder to read. Let's ensure that this scenario includes only essential information for the reader and remove all references to location and range. We'll need to make changes to the step definitions to make sure that a network class is always created, which we can do using an instance variable. We've defaulted the range to 100. If a scenario needs to document specific range, that can still be done by explicitly including a given the range is step. We'll also need to add a step definition that can create a person without the scenario needing to specify where they are located. The step definition gives each person created this way a default location of 0. Let's run Cucumber to check we haven't broken anything. And we're good. Looking at the two new scenarios, listener is within range and listener is out of range, we can see that they also contain incidental details. Since their purpose is to illustrate the shouts should only be heard if listener is within range rule, there's no need to actually document the content of the shout. Let's remove the details that aren't relevant to the range rule. Next, we add a step definition that allows Sean to shout without needing us to specify the exact message. One that allows us to check that Lucy has heard exactly one shout because she's in range of the shouter, and one that allows us to check that Larry hasn't heard any messages at all because he's out of range. And finally, run Cucumber, and we're still green. That's better. We've removed inessential details so that each scenario contains only the information needed to illustrate its business rule. The scenarios would still run green if we removed the steps that set the range of a shout, because the range already has a default value. We're not going to, because since these scenarios are illustrating the rule that deals with the range of a shout, it's an essential part of the context for anyone reading them. A happy side effect is that in order to set the range from our scenario, we've had to make it a configurable property of the system. So, if our business stakeholders ever change their minds about the range, we won't have to go hunting around in the code for where it's been hard-coded. Let's look at the two scenarios that illustrate the rule about range again. Notice how the steps that create Sean, Lucy, and Larry are very similar. When we see steps like this, Gherkin's given when then syntax starts to feel a bit clunky. Imagine if we could just write out a table like this. Well, we're in luck. We can. Gherkin has a special syntax called data tables that allows you to specify tabular data for a step, using pipe characters to mark the boundary between cells. As you can see, the step definition implicitly takes a single argument, which is, as the comment explains, a data table. This object has a rich API for using tabular data. At its most basic, the table is just a two-dimensional array, so Lucy's location can be accessed by getting the value from array cell 2, 1. You can also turn the table into a list of maps, where the first row is used for the map keys and each following row is used for the map values. Now we can easily iterate over these maps and turn them into instances of person. With that done, we can update the other scenario. Now we can check that everything is still green and delete our old step definition, which is now unused. Cucumber strips all the white space surrounding each cell so we can have a nice neat table in the gherkin, but still get clean values in the step definition underneath. Notice we've still had to convert the location from a string to an integer because Cucumber can't know that's the type of value in our table. To improve the readability and maintainability of your step definition, you can have Cucumber automatically convert the table into a list of any class you want. If our person object had a name field, we could automatically create instances of person from this table. But things aren't always that simple. Instead, we'll define a simple whereabouts class to represent the data in the table. We've made it an inner class to the step definition class, as it doesn't form part of our core domain. Then we can create a method annotated with data table type so that Cucumber knows how to convert the table into a list of whereabouts objects. Now, if you declare your table parameter as a generic list, Cucumber will automatically convert the table into a list of the generic type for you. Let's run Cucumber to check that we're still green. And we are. That looks much nicer. People positioned using a table in the feature file. And really clean code that creates and positions people according to the data. The way that we've specified this data is okay, but now our product owner would prefer to express it like this instead. It's always good to please the product owner, but you're worried how we'll handle it in our step definition. Fear not, Cucumber has you covered. If you annotate the method parameter with the transpose annotation, Cucumber will turn each row into a column before passing it to the step definition. Data tables are very useful for setting up data in given steps, but you can also use them for specifying outcomes. One rule that we've been implying, but have never actually explored with an example, is that people can hear more than one shout. So far we've only specified a single message, so let's try writing a scenario where Sean shouts more than once. See how natural it is to use a data table here. We also haven't used any column headers in this case, since the data is all in a single column anyway. So, how do we implement this step definition? Well, the data table has a really handy method called diff that we can use to compare two data tables. Diff will pass if the tables are the same and fail if they're different. Let's run Cucumber to generate the new step definition and paste it into our step definitions class. We'll need the actual messages that Lucy's heard to be stored in an object that looks like a data table so we can compare it to the ones we expect. A list of string will do, so we can just iterate over Lucy's messages and create a new single item list for each row. Now we can pass that list to the diff method on the table of expected messages passed in from the gherkin. Oops, it looks like we made a typo in our scenario. We should have included exclamation marks on the expected messages. Well, at least this gives you a chance to see the nice diff output from Cucumber when the tables are different. We see the expected values prefixed with a minus and the actual values prefixed with a plus. Let's fix just one of these so that you can see how the diff output changes. The matching bagels line no longer has a minus, and for the mismatched row, the actual value still has a minus and the expected value has a plus. Let's fix this last typo and we should be green again. Great. When writing scenarios, Occasionally we want to use a really long piece of data. For example, let's introduce a new rule about the maximum length of a message and add a scenario to illustrate it, making the string just over the boundary of the rule. That's pretty ugly, isn't it? Still, we'll press on and get it to green, then we'll show you how to clean it up. Our existing step definition handles that ugly step with the long message just fine, but the last outcome step is undefined. We could either add a new step definition or parameterize Larry should not hear a shout. Let's modify the existing step definition. Okay, so we have a failing acceptance test. Let's dive down into our solution and implement this new rule. It seems like the network should be responsible for implementing this rule, so let's go to its unit tests. As we explain in more detail in the next lesson, we start by adding a new example to specify this extra responsibility. We'll create a 181 character message like this, and then assert that the message should not be heard when it's broadcast. Let's run that test. Good. It fails. Lucy's still getting the message at the moment. Now, how are we going to implement this? It looks like we're already implementing the proximity rule here in the broadcast method. Let's add another if statement here about the message length. Run the unit test again, and it's passing. Great. The code here has got a little bit messy and hard to read. One very basic move we could make to improve it would be to just extract a couple of temporary variables, one for the range rule and one for the length rule. That's better. This code could be improved even further, of course, but at least we haven't made it any worse. Let's just run the tests to check. Great, everything's still green. Now that we have everything passing again, we can tidy up the gherkin to use a new piece of syntax we've been wanting to tell you about, a docstring. Docstrings allow you to specify a text argument for a step that spans over multiple lines. We could change our step to look like this instead. Now the scenario is much more readable. We have to add a new step definition too. It doesn't need a parameter in the Cucumber expression. The docstring just gets passed as a string argument to the step definition automatically. Now we can fill out the rest of our new step definition. Let's check that we're still green. And we are. We don't use docstrings very often. Having such a lot of data in a test can often make it quite brittle. But when you do need it, it's useful to know about. You might have noticed that we've followed a pattern when we added behaviour to the system during this chapter. First, we expressed the behaviour we wanted in a gherkin scenario, wired up the step definitions, and then ran Cucumber to watch it fail. Then, we found the first class in our domain model that needed to change in order to support the new behaviour. In this case, the network class. We used a unit test to describe how we wanted instances of that class to behave. Then we ran the unit test and watched it fail. We focused in and made changes to the class until its unit tests were passing. When the unit tests were passing, we then made some minor changes to clean up the code and make it more readable. This is the basic test-driven development cycle. Red, green, clean. The technical name for this last cleanup step is refactoring. Refactoring is an ugly name for an extremely valuable activity, improving the design of existing code without changing its behaviour. You can think about it like cleaning up and washing the dishes after you've prepared a meal. Basic housekeeping. But imagine the state of your kitchen if you never made time to do the dishes. Go on, imagine it for a second. Yuck. Well, that's how many code bases end up. The good thing about taking this course is that we're teaching you how to write solid automated tests. And the good thing about having solid automated tests is that you can refactor with confidence, knowing that if you accidentally change the system's behavior, your tests will tell you. Once we're done refactoring, what do we do next? Run Cucumber, of course. In this case, our scenario was passing with a single trip round the inner TDD loop. But sometimes you can spend several hours working through all the unit tests you need to get a single scenario to green. Once the acceptance test is passing, we figure out the next most valuable scenario on our to-do list and start the whole thing all over again. Together, these two loops make the BDD cycle. The outer loop, which starts with an acceptance test, keeps us focused on what the business needs us to do next. The inner loop, where we continuously test, implement, and then refactor small units of code, is where we decide how we'll implement that behavior. Both of these levels of feedback are important. It's sometimes said that your acceptance tests ensure you're building the right thing, and your unit tests ensure you're building the thing right. That's all for this chapter. See you next time. Hello, and welcome back to Cucumber School. Last time, we learned about two very different kinds of loops. First, we used data tables to loop over data in your scenarios. Then we learned about TDD cycles. We saw how the outer loop of TDD helps you to build the right thing, while the inner loop helps you build the thing right. In this lesson, we're going to teach you all about how to work effectively with Cucumber. When we start working on a new scenario, we often take a dive down into the inner TDD loop, where we use a unit testing tool to drive out new classes or modify the behavior of existing ones. When our unit tests are green and the new code is implemented, we return to the Cucumber scenarios to verify whether we have made overall progress or not. If we have lots of Cucumber scenarios, it can be distracting to run all of them each time we do this. We often want to focus on a single scenario, or perhaps just a couple, to get feedback on what we're currently working on. There are several ways to do this in Cucumber, and your IDE may offer other options. We will start by showing some basic filtering using Maven on the command line, before showing you some alternatives. Probably the easiest way to filter is to tell Cucumber to run only a scenario with a particular name. We can pass arguments to Cucumber using the property cucumber.filter.name. This property tells Cucumber to only run scenarios with a name that matches the string provided. In this case, message is too long. The value of the cucumber.filter.name option is actually treated as a regular expression, so you can use your imagination here to run more than one scenario. Let's use it to run all scenarios with the text range in their name. Another way to tell Cucumber to run a specific scenario is to specify the line number of the scenario within a feature file. The message too long scenario starts on line 44 in the feature file. We can use that line number when we run Cucumber. You can even specify multiple line numbers for each file. Let's run 2 shouts as well. We add that line number to the Maven command. You can list several files and lines together like this if you have a specific set of scenarios you want to run. The examples that you've just seen use the -d option to set a Java system property from the command line. If you're working in an IDE, this is less than ideal, but fortunately there are other ways to achieve exactly the same outcome. Let's look at using a property file to set the system properties. Create a property file called cucumber.properties in Source Test Resources, or open it if it already exists in your project. Add the line cucumber.filter.name equals range. When we run Maven, Cucumber picks up the property setting from the file and only runs the range scenarios. The property file is also picked up if you run Cucumber from within your IDE. The benefit of a properties file is that it gets checked in with your code, which means that any settings can be shared by all team members. The final thing I want to show you in this lesson is how to run a single scenario directly from IntelliJ. Right-click on the scenario and select Run Scenario. In this lesson, you've learnt how to filter the set of scenarios to run using scenario names and line numbers from the command line, and also using property files. In the previous lesson, we ran Cucumber using Maven. Maven doesn't actually know how to run Cucumber, but it does know how to run JUnit tests. The Run Cucumber Tests class is called a Cucumber runner and serves as a bridge between Cucumber and JUnit. This allows Cucumber to be integrated into any development environment or build server that understands JUnit, which is most of them. As you can see, there's not much in the Cucumber runner class, but you can control how Cucumber runs by using the Cucumber options annotation. We'll use this to show you how to filter using tags. First, let's remove the filter from Cucumber properties. I'll explain the Cucumber publish quiet property later in this chapter. Now, Cucumber will run all scenarios. We'll put a focus tag right here above this scenario. Tags start with an @ sign and are case sensitive. Now let's add a tag expression to the Cucumber options annotation, which Cucumber will use to filter the scenarios run. Now we can run only the scenarios tagged with focus. There should be only one. Yep. It's entirely up to you what you name your tags. When we're working on a particular area of the application, it is common to use a temporary tag like this, which we'll remove before we check our code into source control. Tags can be used for other purposes as well. If you have lots of scenarios, it can be time-consuming to run them all every time. For example, you can tag a few of them with smoke and run only those before you check in code to source control. Running just the smoke tests will give you a certain level of confidence that nothing is broken without having to run them all. If you're running Cucumber on a continuous integration server as well, you could run all the scenarios there, detecting any regressions you might have missed by only running the smoke tests locally. Tags give you a way to organize your scenarios that cut across feature files. You can think of them like sticky labels you might put into a book to mark interesting pages that you want to refer back to. Some teams also use tags to reference external documents, for example, tickets in an issue tracker or planning tool. Let's pretend we are using an issue tracker while working on Shouty, and all the behavior we have built so far is related to the issue number 11. We could tag the whole feature file with this single line at the top. All the scenarios within that file now inherit that tag. So if we change the tag expression in Cucumber options, Cucumber will run all the scenarios in the feature file. You can use more complex tag expressions to select the scenarios you want to run. For example, you could use a tag expression to exclude all the scenarios tagged as slow. Then rewrite the tag expression in Cucumber options using the not keyword. Now when you run Cucumber, the slow scenarios won't be run. Let's tidy up by removing the tag filter from Cucumber options. You can read about how to build more complicated tag expressions on the Cucumber website. There's one more thing to learn about tags. They can be combined with hooks so that you can be selective about which hooks to run when. We will cover that in a future chapter. Cucumber is first and foremost a tool that facilitates a common understanding between people on a project. Imagine our customers were cats. We could write our features in English, but the cats would obviously not understand that. So I'll show you how to write a scenario in lolcat instead. You can get a list of all the supported languages with the i18n help command. Cucumber supports over 70 different languages thanks to contributions from people from all over the world. To see the translation of the gherkin keywords for a particular language, just replace help with the language code. Now, create a new feature file in source test resources called cat.feature. The first line tells Cucumber which language the feature file is written in. Cucumber then expects the gherkin keywords to be in lolcat. The step is undefined, but we can quickly generate it by running Cucumber. Cucumber has generated a step definition name in snake case, each word separated by an underscore. Although we prefer this naming convention for test names, it's more idiomatic to use camel case naming in Java. So let's go back and add another line to our property file. Now when we run Cucumber, the snippet method name is generated in camel case. Implementing step definitions in non-English languages is exactly the same as in English, so we won't go any further with the lolcat implementation just now. Let's delete the cat feature file and check that we're still green. Notice that the scenarios in hereshout.feature are being run in the order that they occur in the feature file. That's fine, but there's a chance that since they always run in the same order, we might accidentally make one scenario dependent on some other scenario. Each scenario should be isolated. Its results should not depend on the outcome of any other scenario. To help you catch any dependencies between your scenarios, Cucumber can be told to run your scenarios in a random order. To do this, set the cucumber.execution.order property in the property file. Now when we run Cucumber, the scenarios are run in a random order. Now there's almost no chance of a dependency between scenarios slipping through without being noticed. A full list of Cucumber's configuration properties can also be found on the Cucumber website. There's a help page included with Cucumber which can be printed using Maven. This lists both the names of the command line options and the system properties. That's quite a lot to digest, but to make Cucumber really useful to your team, it's good to spend some time learning the details of how to configure it. In this lesson, we showcased two of Cucumber's configuration options, and you learned how to write your scenarios in different spoken languages. Remember the help information that we got Cucumber to print in the last lesson? In this lesson, we're going to concentrate on configuring Cucumber's output using plugins. So far, every time we have run Cucumber, it has printed the features back to us in the console. This is called the pretty formatter. Cucumber can report results in other formats, some of which are useful for generating reports. Let's try the HTML plugin. When we use the HTML plugin, we simply append a colon followed by the file path where we want the report written. Now let's take a look at the HTML that has been generated. As you can see, this generates a nicely structured HTML page that details what scenarios were run and whether the system behaved as expected. You probably noticed that we still got the pretty output in the console. That's because we have specified the pretty plugin in the Cucumber options annotation in runcucumbertests.java. Let's delete that and run Maven again. Notice that this time the only console output is a summary of the number of tests being run. There's no pretty output because we removed it from Cucumber options annotation. Cucumber combines the plugins specified on the command line with those specified in the Cucumber options annotation. There's also a progress formatter, which just prints out a single character for each step. There's also a JUnit formatter that outputs results in an XML format which many continuous integration servers will turn into a nice report. We can ask Cucumber to run with more than one plugin, as we saw earlier when we used the Pretty plugin and the HTML plugin at the same time. There's a limitation that only one plugin can write to the console at the same time. Let's try to use the Progress and JUnit plugin together. We can still use both plugins at the same time, but we need to tell Cucumber to write one of them to a file, not to the console, by appending a colon and a file path. The JUnit XML has been written to a file. The last plugin I want to show you is rather special, the Rerun Formatter. Before we try it out, let's make one of our scenarios fail. While we're at it, let's put Pretty plugin back into Cucumber options. Now let's run Maven again using the Rerun plugin, writing its output to a text file. Let's call it rerun.txt. We can see in the console that the toShouts scenario has failed. Let's look at what's in that rerun text file. It's a list of the scenarios that failed, and the format looks familiar, doesn't it? It's using the line number filtering format that we showed you in an earlier lesson. This is really useful when you have a few failing scenarios and you want to rerun only the ones that failed. We tell Cucumber to run only the failed scenarios by pointing it at the rerun file. This is a big time saver when you're in the middle of refactoring where you have broken a few scenarios and you are working yourself back to green. Let's fix the scenario and rerun the failing scenario again. Great, we're back to green. In the last lesson, we saw the output generated by the HTML plugin. This is a great way for your business colleagues and customers to engage with the development of the product. Since the scenarios are written in business language, they act as documentation that everyone interested in the product can understand. And because the results are color-coded green, if the system behaves as expected, or red if it doesn't, everyone can see what behavior has been implemented. The challenge is making sure that this documentation is easily available. Feature files are usually checked into source control along with the source code, which isn't a great way of making it accessible to less technical team members. The HTML output can be shared, but it needs to be stored somewhere that everyone has access to, such as on your intranet or wiki. That's something that your team has to configure themselves. Since Cucumber JVM 6.6.0, there has been a new feature that allows you to automatically publish the results online to a free service called Cucumber Reports. Ensure that you're using Cucumber JVM 6.6.0 or later, and that Cucumber Publish Quiet is set to false. At the time of recording, the IntelliJ plugin doesn't support Cucumber 6, so we have to use Maven to run Cucumber. Now Cucumber helpfully prints out a banner telling you how to publish your results to Cucumber Reports. Let's follow the instructions from the banner and set Cucumber Publish Enabled to True. Now we can run Cucumber again and we get a different banner output. The unique URL in this banner is the address of your published report. Open the URL and you'll find your report published in the same format as the HTML plugin. Now you can share the report just by sharing the URL. You also get some extra information about the run that generated the report. If you publish reports from a recognized CI server, then even more information is gathered. You might have noticed the warning in the banner that says the report will self-destruct. To prevent a report from being deleted, it has to be associated with an authenticated account. Follow the link in the report to authenticate your account. You can then retrieve your Cucumber Reports Publish token. Reports associated with a Publish token will be kept until explicitly deleted. During development, you probably won't want to publish a report after every build, and you might prefer not to see the banner output telling you about Cucumber Reports. Let's fix this in the properties file by removing the Cucumber Publish Enable property and adding the Cucumber Publish Quiet property. Now when we run Cucumber, no report is published and no banner advertising Cucumber Reports is output. Cucumber Reports is under active development, so expect to see many more useful features coming in the next few months.